Problem number 1. Here we have a field which has the shape of a rectangle. So let us draw a rectangle. And then we attach two semicircles at the opposite sides. Say the radius of the semicircle is r. So we have here r and over there r. And let the length of the rectangle equals x. Okay. Now we want to find the radius that maximize the area. So let us write the area function for this field. So the area will be the length of the rectangle multiplied by 2r. So 2rx, and then plus the area of two semicircles. So the area of this semicircle is 1/2 of pi r squared, and the same thing as this other semicircle. So basically we have an area of a circle plus pi r squared. Okay. Now we want to write a as a function of one variable only. To do so we need another information. So here we use the information that the perimeter of the field equals 100. So let us count what is the perimeter of this field. 100 equals to x. So we have 2x plus, what is the circumference of a circle? The circumference of a circle with radius r is 2 pi r. So here we have pi r, and one more here we have another pi r. So we have 2 pi r. Okay. Now from here we have 2x equals 100 minus 2 pi r. Or you can solve it for x. X equals 50 minus pi r. So now if we plug in this x to a here, so put this 50 minus pi r instead of x to r multiplied by 50 minus pi r plus pi r squared. And if we simplify, we have 100r minus pi r squared. Standard procedure to find the maximum value or the point that maximize a function is first to find the critical points, and if our problem is on the closed interval, then we will check the value of the function at the critical numbers and at the endpoints. So now first we take the derivative of a, which is equal to 100 minus 2 pi r, and we set it equal to 0 because that is the definition of critical numbers, the point where the derivative equal to 0. So now we solving for r. 100 equals 2 pi r, so r equals to 100 divided by 2 pi, which is 50 over pi. Okay. Now let us look at back the problem. So here in the problem it says that twice the radius of the semicircle is at most 18. So basically it says that 2r is at most 18. So we know that 2r is at most 18, and r, the smallest possible value for r is 0. So r itself will be between 0 and 9. Okay. So now we have one critical number and we have two endpoints, 0 and 9. So what we need to do now is to check the value of a at 0, 9 and 50 over pi, and compare which value of a that make the biggest value for a. So a of 0, plug it here, we have a of 0 will be 0, and a of 9 and a of 50 over pi. Okay, so you can check it by yourself what is a of 9 and a of 50 over pi, but you will find out that a of 9 is the biggest one, so the answer is 9.